What is cloud computing? Surely you have heard the buzz surrounding cloud, but its meaning is often nebulous. See what I did there? The cloud isn't a magical dimension where elves and fairies solve all our problems. The cloud is computers. Lots of computers in a remote location. The most concise definition I came across: the practice of using a network of remote servers hosted on the internet to store, manage, and process data, rather than a local server or a personal computer. There's a reason why you've heard the cloud buzzword so much. It's already changed everything, from the mobile applications we use every day to make the world a better place, to the host of business services that most of us never see, but make the world we know today function efficiently. Autodesk believes their future as a company is in the cloud, and they're going all in. Their mobile and cloud-based applications are growing quickly in number. A360, PLM 360, and Fusion 360 are just the beginning. In 2012, Autodesk brought their simulation products to the cloud. First, under the Simulation 360 brand, they later became Flex products. Autodesk CFD, Simulation Mechanical, and MoldFlow Insight all had Flex variants. These versions of the software were different in two key ways. They were licensed on a term basis. These were some of the first Autodesk products to be offered as a service. And second, they allowed users to launch simulation solving tasks to the cloud. In 2016, with the 2017 product releases, these products were retired. Instead, all users of the 2017 CFD and MoldFlow Insight products can utilize cloud solving, provided they have the cloud credits to do so. As of this recording, Simulation Mechanical does not offer this service. So, what are the benefits of the cloud? For most users, it means access to more advanced hardware. Some of us are lucky enough to have powerful desktop workstations, but most have machines that are built for CAD at most. While the simulation products perform admirably on CAD machines, the more advanced and detailed models benefit greatly from faster clock speeds, more processor cores, and larger banks of system memory. It's scalable. We'll get into the different solving scenarios in detail in a moment, but one of the primary benefits the cloud offers over local solving is the ability to solve multiple simulations in parallel. For example, solving multiple design candidates that need to be compared. Launch them all at the same time and get them back at the same time, rather than waiting for each design to solve sequentially. This effectively gives you more licenses, temporarily, when you need them. The cloud is reliable. When my local machine goes down, I have to wait until it's fixed to resume working. If I need parts, that could mean days of downtime. The cloud is basically always up and ready. If they have software and hardware problems on a node, your job just goes to another one. It's secure. Yes, I'm going there. There is a segment of humanity that distrusts the cloud. It seems to be hardwired into us. We feel we can do a better job protecting our data locally than any cloud service could. Autodesk and other cloud service providers have an uphill battle to wage in our hearts and minds that they are slowly winning. The fact is that our data is not safe on our local systems. Data loss due to hardware failure, user error, and natural disasters is much more common within our organizations than it is in the cloud, where they spend a lot more time and money on data protection than the average IT department ever could. The connection protocols and policies that you trust with your personal and financial information every day are in use here as well. You already trust the cloud. You just may not know it yet. But don't take my word for it. Check out the Autodesk Trust Center for more information. Let's go over the options for solving an Autodesk CFD. You can think of CFD as two major components: the graphical user interface, called the design study environment, and the solver, which comes in several flavors depending on your needs. Check out our YouTube channel for a great video on the differences between these solvers, by the way. Anyway, the DSC is what the user sees when they open CFD. It's where you set up and mesh the study. When you hit solve, it sends the setup to the solver. That's where the math magic happens. As the solving is completed, results are sent back to the DSE. The user then interrogates results. Actually, what I've shown you here is more like a remote solve, which I'll discuss in more detail in a moment. More commonly, the DSE and the solver are on the same machine. It works the same way, but a single machine's resources are used for both the user interface and the number crunching. We call this a local solve. There are 4 configurations for CFD solving: local, remote, cloud, and cluster. Local solve is the default. It uses one machine for pre and post processing, or setups and results, and solving. You can control how much of your computer's resources are allocated to the solver, but by default it will tax your CPU at about 100%, depending on how many physical cores your system has. While for most workstation class machines, this will not prevent you from continuing to work on other things, including CAD, you will probably notice a drop in performance. Solve times are generally tied to processor clock speed and the number of cores. CFD will use cores and powers of 2. For example, dual-core, quad-core, and 8-core processors will be fully utilized. I have a 6-core processor. 2 cores are ignored by CFD. Hyper-threading is not supported. RAM is important. The more system memory you have, the larger your mesh can be without using the hard drive swap file. If you run out of RAM, the solve will slow to a crawl, and you may as well stop and make your problem simpler. Multiple jobs can be queued up for the solver, but it will always solve sequentially, not in parallel. The machine will need a license for both the DSE and the solver. You can close the DSE while it solves. Reopening the model will download the latest results from the solver. This can save some resources. The machine does have to stay on, though, as the solver is running in the background. Remote solving means the DSE and the solver are on different machines. The machine with the DSE is like a client, and the solver machine is a server, although it does not have to be a server in the hardware sense. You'll install the software on both machines. The client side will only pull a DSE license, and the server will pull a solver license. The server does work the same as local solve in that it can only solve one job at a time. However, with this configuration, you could run more than one job in parallel if you have more than one solver machine. We're often asked why CFD is sold as 2 licensed products when both are required for analysis. This is why. Depending on your needs, you may want multiple DSE licenses so several users can set up and read results at the same time, but you only need one solve running at a given time. Or the reverse may be true. You only have one user, but you want the ability to solve multiple jobs in parallel locally. The client machine is not burdened with the solving, and so can continue to work on other things, including its own local solve if there's a license available. We typically see this kind of setup when an organization wants to give their users less expensive CAD class machines, but they'll designate one high-end workstation to do the solves. And of course, the star of this show is the cloud solve. Solving tasks are handled by off-site data centers through the Autodesk Cloud Service. From the client side, it really looks no different. The same DSE is used. The hardware used cloud side is probably better than yours. Just saying. You could solve as many jobs as you want in parallel, provided you have the credits. I'll talk about credits in a minute. It requires a license to launch a job, but it doesn't consume it while it runs. So you can run a local solve at the same time. Keep in mind that you have to have the appropriate license for the job you're launching. So you can't launch a job that uses advanced solver features unless you have an advanced solver license. You'll still be able to monitor the job as it runs, so it's much like a local solve. You'll notice the convergence plot moves in spurts as the results are downloaded in chunks. Other than that, the user experience is the same. The client machine can shut down entirely. You could launch a job from a laptop in an airport before you take off, then download the results when you land. Just open the file and it will download automatically. If a job fails, you don't get charged. You only pay when you get results. However, bad results are on you. The cluster solve is rarely used. This is like a private cloud. The user would set up a group of machines that would work together as one to solve a job. It can help with very large problems. Usually it's companies that are not yet permitted to use cloud services that opt for such a setup. It also gets very expensive. The hardware costs add up, and each node needs a solver license. There are some very specific hardware and software requirements. If you have a need for such a setup, please reach out to us. We'd love to help. To use cloud solving, you'll need a couple things. Head over to Autodesk account. Check to see if you have access to the cloud service entitlement. This is a separate purchase comparable to a pack of cloud credits. Reach out to us if this is not already on your contract. We'll work it out. Contract managers control who has access to the entitlement, so even if it's been purchased, you may not see it unless you have been granted access by your manager. Again, we can walk you through assigning access to this if you need help. You'll need cloud credits. These credits are a universal currency that Autodesk uses to pay for cloud services like AutoCAD rendering or CFD cloud solves. You may already have some. Check an Autodesk account to find out. Again, your contract manager can control how many credits single users get access to. These can be purchased online, but you'll want to reach out to us if you make credit purchases. You never know, your sales guy might be feeling generous. Jobs are 15 credits apiece. Sign into the A360 service in the DSC interface, through the A360 desktop app running in your system tray, or in the Simulation Job Manager. If you forget, it will prompt you to sign in when you launch a cloud solve. You can launch individual jobs right in the Solve dialog. Just switch the Solver computer to cloud. Multiple jobs can be launched from the Solver Manager. Just make sure Solver computer is set to cloud. Remember, each job is 15 credits. Simulation Job Manager will launch automatically when you solve. You'll see jobs in here just like your local solves. Mousing over the thumbnails can give you more information about the status of the job. Finally, what are the limitations of cloud solving? Well, most obviously it costs more. So we use it for the bigger jobs. We always recommend multiple runs of a scenario in CFD. The first one should be default settings, including default mesh, just to see if you set it up properly. In order to have confidence that your mesh is adequate, you run progressively more detailed meshes until the results stop changing. They take longer and longer to run. Do your first iterations locally. Once you're confident in the setup, refine your mesh and send those jobs to the cloud. Or, like me, you may find yourself on the road and in need of CFD, but your laptop just isn't going to cut it. Send it up to the cloud. Data transfer becomes a factor. You're now uploading data to the cloud and downloading results. The results will take longer, and of course performance will vary with your connection speed and the size of the model. I will say this, if you were an early adopter of the cloud products and you were unhappy with transfer speeds in the past, I encourage you to try it again. It's come a long way, and they're always working to improve it. The runs will stop after 3 days. The job will finish and you'll get the latest results. After that, you can launch again and continue at a charge of 15 more credits. 3 days is a long time, even for a very complex problem, so few users will bump up against this limitation. As stated earlier, cloud solves check for a license in order to launch. If that license is already consumed by a local solve and you have no other licenses, the cloud won't launch. So launch your cloud solve first, then your local solve.